In this video, we're going to explore a way of solving quadratic equations that's different than what we've done in the past. So just for starters, if we have something like x squared equals 4, in the past, we've always started by getting one side equal to 0 if it didn't already have a 0 on one side. And then we asked ourselves if what we have on the left side in this case can factor. And of course, this one does because it's a difference of squares. So it factors into x plus 2 and x minus 2. So we end up getting x equals negative 2 and x equals positive 2. So this is just utilizing the skills that we already have. But what we're going to do is we're going to introduce an idea called the square root property. That's an alternate way of approaching a problem like this. And ultimately, this will be part of how we'll learn to solve quadratic equations that don't factor. So in the square root property, what you want to do is you want to have the square part by itself. I'll put a little note here. We get the square part, the square term by itself. Okay. So, of course, in this case, it's already by itself. Now, utilizing what we know about the fact that when we were solving square root equations, we would square both sides and kind of have the square root and square zap each other, so to speak. We're going to do the same thing here. So if x squared is equal to 4, I'm going to go ahead and take the square root. And if I take the square root of x squared, I get x, sort of. Um, the truth is, if I take the square root of x squared, I actually get the absolute value of x. But we're not going to actually use the absolute value symbols here. Here's what we're going to do instead. We're going to understand that when you square an x and get 4, that yes, that x could be, it would be 2, but for now I'm just going to say the square root of 4, but it could also be negative square root of 4, right? Or in other words, it could be plus 2 or it could be negative 2, right? And we, of course, understand why, right? Negative 2 squared is 4 in the same way that 2 squared is 4. So the square root property says if you have the square by itself, go ahead and then take the square root of the other side to get your x, but you have to remember that it could either be plus or minus. So x is equal to plus or minus 2, which is, of course, exactly the same thing that we got over here. All right, so x squared equals 20. Now, let's just make a note here that if I subtract 20 from both sides, um, this here does not factor. And it doesn't factor because 20 is not a perfect square. Okay, so we're not going to approach the problem this way, so you can already see why it's helpful to have another way of approaching it. So x squared equals 20. Well, the square is by itself, so I'm going to go ahead and take the square root of 20, but understand it could be the positive square root of 20 or the negative square root of 20, that if I was to square it, I would get 20 back again. Now, the other thing that we are responsible for doing in these problems is to make sure that the radical that we come up with can't be simplified. So um, we look at 20. We notice there's a perfect square of 4 in 20. So I'll do that and continue to have the plus or minus there. So x is equal to plus or minus 2 root 5. And so that's fine right there to write it like that. But I do want to just emphasize, understand that this means there are two distinct solutions: negative 2 square root of 5 and positive 2 square root of 5. Now, in an example like the one on the right here, right now the square is not by itself, right? So I would, of course, want to start this by subtracting 88 from both sides. And then I still have this 2 out here, so I think I also want to go ahead and divide by 2 on both sides. And so we get x squared is equal to negative 44. All right. So following the same process, I end up with x is equal to, go ahead and take the square root of negative 44, but remember plus or minus on the outside. Now, this is interesting, right? Because before we studied complex numbers, we thought that we could never take the square root of a negative. But now we understand that, okay, sometimes we can get complex answers or imaginary number answers. So when we see that negative, remember from our study of complex numbers, we would say, let's turn that into negative 1 times. And then 44, does that have any perfect squares? Yes, it does. It has a 4 times 11. So this can break up into square root of negative 1, square root of 4, square root of 11. And of course, when you see that square root of negative 1, that's an I. Square root of 4 is, of course, 2 times the square root of 11. And this is fine right here. However, it's kind of convention to have the 2 in front of the I. And so what I would do as kind of a final answer here is I'd say x is equal to 2I square root of 11, or x is equal to negative 2I square root of 11. All right, so the time that we want to use this square root property is, notice that all of the examples so far do not have an x term that's only raised to the first power. It's only x to the second power. So that's the case in all three of these. So you have something squared, and then the rest of it is numbers. All right, so why don't you press pause and give the example on the left here a try yourself, and then go ahead and press play and see my solution. All right, so we'll want to add 48 to both sides here. So we have 3x squared is equal to 48. Get the x squared by itself before doing anything else. So x squared is equal to 16. All right. And when you see this, you might immediately think, oh, 4, cool. But remember, x squared equals 16. It's not just 4, it's plus or minus 4. All right. So square root of 16 there. All right. So two different answers, positive 4 and negative 4. Now, the example on the right here is a little bit different flavor from the other ones, in that you have x minus 3 in parentheses, and that's being squared. The thing here is, though, that you can approach it in the same way. So let's just switch colors here. So x minus 3 squared, the square is all by itself. So we'll go ahead and say this is x minus 3 is equal to plus or minus the square root of 4. X minus 3 equals plus or minus 2. Okay. Now, if after applying the square root property, x is not by itself at this point, then you have a little bit more algebra to do. And so what I would definitely suggest is, at this point, breaking it up like this into two separate equations. Um, you can do algebra with plus or minus 2 in there, but this makes it really clear what you're doing. So you solve that little equation and get x equals 1. And we solve this little equation and get x equals 5. Right. Here's another one where there's more complicated things happening inside the base here where the stuff that's being squared. But first, I must get the square by itself. Right, so we have 4x minus 3 squared is equal to 24. The square is by itself, so I can go ahead and apply the square root property now. So plus or minus the square root of 24. Now, before I proceed any further, let's note that the square root of 24 can be simplified. In kind of a longer problem like this, it might not be a terrible idea to kind of do your simplification over here on the side so you don't have to continue to rewrite everything. So are there any perfect squares in 24? Yes, there are, right? 4 times 6 is 24. So, oops, didn't mean to write that square root again. What I meant to write was the square root of 4 times the square root of 6 becomes 2 times the square root of 6. So you might just do this on the side. So then in a more condensed way, or I guess quicker way, you can write 4x minus 3 is plus or minus 2 root 6. So just get that simplification done right off the bat. All right. And now, if you want to add 3 to both sides, you certainly can do that. Um, or if that's a little uncomfortable, you can break it up into two separate equations. Add 3 to both sides. So we have 4x is equal to 3 minus 2 root 6, and 4x is equal to 3 plus 2 root 6. And then lastly, we'll divide by 4 on both sides. So you can keep this as one big fraction on the right. That would be okay. Or if you want to break it up into two separate fractions, that's okay too. So if I break it up, it'll be 3/4 minus 2 root 6 over 4 and 3/4 plus 2 root 6 over 4. Although you can see now that I've broken it up into separate fractions, I guess there's a little bit more work to do because if I divide by 2 on top and bottom, that fraction reduces. So my final answer here, x equals 3/4 minus the square root of 6 over 2, and x is equal to 3/4 plus the square root of 6 over 2. All right. Two more examples here. I think at this point it would be wise to press pause, try the next two yourself, this one and this one, and then press play and see what my solution looks like. Okay, so here I'm going to add 5 to both sides. And something that I just want to contrast with the previous example. Here I have 4 outside of the parentheses that are being squared. In the last problem, the 4 was inside. So when I got to this point, 4x minus 3 squared, that's when I applied the square root property um, because that 4 was trapped in those parentheses. However, here, I'm not ready to apply the square root property yet because the 4 is outside of what's being squared. So I'd want to divide by 4 on both sides before proceeding. And so I end up with x plus 3 squared on the left is equal to 8 on the right. So x plus 3 is equal to plus or minus the square root of 8. Square root of 8 over on the side here does have a perfect square inside of it, so this will become 2 root 2. So x plus 3 is equal to 2 root 2, plus or minus 2 root 2, of course. Now, I do just want to show you, since in the problem so far, at this stage, I've always broken it up into two separate equations. So, like right here, I had plus or minus 2 root 6, and then I broke it up into two separate equations to do the algebra to it. It is okay if you just say to yourself, I'm going to go ahead and subtract 3 from this, and then that would mean you'd have negative 3 plus or minus 2 root 2. And then at that stage, you could list them out separately. That'd be fine. So there's nothing wrong with doing algebra on an equation that has plus or minus. Just don't lose that plus or minus. And at the end, don't forget what that plus or minus is telling you. It's telling you that there are two distinct solutions there. Okay, so for this one, what happens is when I add 5, I end up with still having a negative on the right side of the equation. So, but at the same time, the square is now by itself, so I'm ready to do the square root property. So plus or minus the square root of negative 18. Okay, now over on the side, I'm going to see if that square root of negative 18 can be simplified. And of course it can, because it's definitely got this negative in that I want to be able to pull out as an I. So negative 1 times, and of course 9 is a perfect square. So we're going to end up with complex solutions here, right? Solutions that have an imaginary part to them. I know that seems a little bit strange, but that's something that you're going to deal with in pre-calculus and in calculus and beyond, is that uh, we talked a little bit about when we introduced imaginary numbers that there are very real life applications to imaginary numbers. So when we get solutions that are imaginary, that is going to be important too. So we don't want to lose track of them. So we'll go ahead and turn this into that. And this one, I'll go ahead and solve this with the plus or minus in so you can see how this works. But if at all in doubt, break it up into two separate equations first. All right, and then we'll divide by 2 on both sides. So y is equal to negative 1 plus or minus 3i root 2 over 2. And then I can break these up, right? Y is equal to negative 1 half plus 3i root 2 over 2. And y equals negative 1 half minus 3i root 2 over 2. Okay. One last thing I just want to point out about solving equations when there might be negatives under the square root is we do need to pay attention to what they're asking us to do. So if they ask us to solve an equation and they're not specific about what types of answers they want. So if you see something like this, solve this, then you absolutely, if you end up with imaginary numbers, you would absolutely give those as answers. Okay. If on the other hand, um, let me just put this on a separate page so that it's not being confused with the question I actually asked. But if on the other hand, I said this, find all real solutions to the same one we just did. Okay. The fact that we ended up with, after some work, 2y plus 1 is equal to plus or minus the square root of negative 18. The moment I hit that spot, if they were only asking for the real solutions, then I would just stop and I would say no real solution. All right. So as you're doing homework, just keep an eye out for that. If they're specifically asking for all real solutions, well, you can't take a square root of a negative and get a real number. However, if they are just asking you to solve and they're not specifying that they want real solutions, then you know how to handle negatives under the square root, right? You go ahead and use I for an imaginary number.